welcome back to Chapter 4, Linear Relationships. Today we're looking at Exercise 4C, Sketching Linear Graphs. When I film these pre-lesson videos, I don't usually look at the Are You Ready? But this one here is really important. We're going to start by labeling each of the pronumerals in the general rule for a linear graph, and that's given on the screen here, nice and big and bold. Y equals mx plus c, with what each of those mean. So just as a bit of review, y is what we call our dependent variable. Okay, it has a few different names. I prefer dependent variable. So this is the one that will change depending on x, the independent variable. So these here are just coordinate points. We don't need to do anything with them. The important stuff here is m and c. So m is what we refer to as our gradient, okay? The gradient tells us how much y will change with each increase in x. So every time I add 1 to the x value, how much is y going to change by? C is what we call the y-intercept. So when we graph these equations, okay, this is where the line will go through on the graph. We'll jump into the lesson now. So to sketch a linear graph, you really only need 2 points. There are a few different methods you can use. The y-intercept method or intercept gradient method is nice and easy, and it's the one I definitely prefer to use. You could also just use the x and y intercepts if you like. Realistically, you should be ruling all of your axes out neatly using a ruler and drawing all of your lines nice and straight. So doesn't matter which 2 points you pick. We'll jump in. I've only got one example for you today. So we're going to sketch the graph of y equals 2x minus 3. And we're not going to worry about the rest of this today because we don't need it. It will come in a little bit later. But for today, we don't actually need to calculate those two things. I don't think it comes up beyond the extension. So we're just going to sketch the graph of y equals 2x minus 3. All right, so to do that, I'm going to use the gradient intercept method, okay? We're going to write let. Now, let just means I'm substituting a point or I'm picking a value for one of these. Y is my dependent variable, so I will pick something for x. To find the y-intercept, I want x to be 0. So I always substitute x equals 0 as my first step when I want to plot a linear equation. That will give me y equals 2 times 0 minus 3. Of course, 2 times 0 is 0, so I get y equals negative 3. Therefore, and that's what these 3 dots mean, a bit like a bowling ball, we have a point at 0, negative 3. Okay, is a point on the line. Step 2, we're going to let x. This time I pick x equals 1. So before, when I was talking about the gradient is the number that y will increase by every time I increase x by 1. If I've gone x equals 0, I'm going to choose one more point away from that. The only time I don't do that is if I have a gradient that is a fraction, in which case whatever the denominator is, so if I had 2/5, I would pick x equals 5 just to cancel out that fraction and the denominator and to avoid getting a fraction as my answer. So that's the only time I pick any number other than 1. If my coefficient is a whole number, I will pick 1 as my second value. If it's a fraction, whatever the denominator is in the gradient is what I will pick for my x value instead. And we're going to continue. We're going to substitute. So y equals 2 times 1, take 3. 2 times 1 is obviously just 2. So 2 take 3 is negative 1. Therefore, we have a point at 1, negative 1. And that's all we need. So we have 2 points. We can now graph the equation, the literal equation or the linear equation on the axis. Okay, my first point here, 0, negative 3, I'm going to start at 0. I'm not moving anywhere because x is 0, and I'm going to go down to -3. So this here in the equation, okay, was our y-intercept. So if we looked at y equals 2x minus 3, here the -3, okay, that is our y-intercept, and that's where that number is. So that checks out. We've graphed that one. We'll go to the next point. We'll go across to x is +1, and we'll go down to -1 in the y-axis, and we'll draw a point there. This is going to be difficult for me to draw anyway on a graphics tablet, so you're going to forgive my shoddy line. I'm going to maybe, I can't be bothered grabbing a ruler for it. Okay, we'll live. Okay, so to draw the line now, we just go straight through those 2 points. Oh, that was much better. Okay. You will obviously use a ruler and you won't be doing it digitally, so it's going to be much easier for you. I cannot use a ruler on the graphics tablet that I've got handy anyway. My last point to you is to write the rule of the equation next to it. What that means is that you can do all questions, say question 1, A, B, C, D, on the same axes. As long as you're labeling them, I'm okay with you only drawing one axis and drawing every single graph from that rule. Finally, the gradient. Here, the gradient was 2. I'm starting here at the y-intercept. If I go across 1 and up 2, I get a gradient of rise over run, and we'll be covering this, I think, in the next exercise, which is 2 over 1 or just 2. Okay, so that's also where that number comes from. So you wouldn't even have to do this if you didn't want. You could jump straight to, okay, that's my y-intercept. I'm going to go across 1 and up 2, because this is the same thing, 2 holes. Okay, if it was 2/3, you could go across 3 and up 2, and that would tell you which way it goes. And that would give you your second point as well, using just a graphical method. So there's 2 different ways to plot some points. You could, of course, pick any value for one. I could have gone with 2 or 3, and then I would have had to make sure that my axes represented those numbers instead. As always, message me if you need any help, guys, and good luck with the work.